Hi everyone, this is Chirag. This is my first video for this channel where I'll be covering topics like AI, open source models, and research paper. So the topic for today is DeepSeek MLA. This is the paper. So this paper was published in May 2024. This is one of the reasons why DeepSeek is so popular today, and we'll be diving deep into this paper. This is the main concepts and what it covers. So yeah, so here's the problem. LLM needs to store tons of memory just to work with long context. With long context, you'll need lot of memory, lots of GPU space. So for example, every token you're storing has around 20,000 numbers just for each token. So let's say you have 100k context values out there. So it will take up to 240 GB of cache. So you're seeing the issue here. Say an example, H100, which is one of the most powerful chips out there, right? So a 240 GB cache will literally not fit in H100. So the memory is becoming a bottleneck over here. So the engineers in DeepSeek, they asked, what if we don't need to store all 20,000 numbers? What if we can compress them? And here's the thing, like 128 attention heads are like kind of redundant. You're looking at similar informations, so those 20,000 numbers are just noise, and you can compress it down to 512 dimensions. So this is what we do. We squish the key and value vectors into one small latent vector with 512 dimensions. Now when you need to compute attention, you decompress it on the fly. So this is not a lossy compression because it's not done on top of pre-trained model. It is done while training. So you don't have any issue, like you don't suffer from any losses out there. But here's the catch. Positional encoding is called ROPE. So it's position dependent, right? So what if you rotate the vector? The math breaks. You can't decompress it. So DeepSeek split into two lanes, one lane for content which is compressed and another for position information which stays uncompressed and gets rotated properly. So you add the two scores together and yeah, you get the compression where it works and you don't need to fight the rope problem. So it led to pretty amazing results out there. Yeah, so 93.3% improvement in memory, like smaller KV cache, 5.76 times better, faster token generation, same model, same quality, same model quality actually. This is what led DeepSeek V2 possible, then V3, then R1. Every big DeepSeek model out there is now using this since MLA. So yeah, this is the summary for the paper. Hope you enjoyed it. I'll be covering GRPU in the next video. See you. Bye.